Hey guys, welcome to my channel, and in today's video we are going to solve one more LeetCode question, that is question number 463, island parameter. So this is an easy level question and this is being asked by these many companies. So let's see what this question is all about. So in this question we are given a grid which is representing a map where grid ij represents, if the grid ij is equivalent to 1, then it represents a land, and if the value of grid ij is equivalent to 0, then it's representing water. So grid cells are connected horizontally or vertically, not diagonally. The grid is completely surrounded by water, and that is exactly one island, that is one or more connected land cells. So if there are more cells with value equivalent to 1, they are considered as island and they has to be in a connected state. So we'll see that in diagram. That will be more understandable. So in this diagram we can see that this yellow highlighted area is the island, and we need to calculate the parameter of it, which is simply the addition of all these yellow edges, and we will get 16, and this is the answer. So this is given in the question where we have to find out the island, and island doesn't have lakes, meaning the water inside isn't connected to the water around the island. One cell is square and side length is 1. The grid is rectangular. Width and height doesn't exceed 100, and we have to determine the parameter. So these are the instructions which are given in this question. Now let's see how we can solve this question. So we can see in this diagram, as I already said, that the sum of these yellow edges is going to be equivalent to 16, and that is what parameter is. So how we are figuring out that this is a part of an island and we have to add it up as a result. So let's see what can be the brute force approach for that. So firstly I will start traversing this grid because at the end I want to find out the island. For that I need to traverse all the cells. So there are two things that is already given in this question, and as I always say, that we need to search our question and read our question really well so that we'll get the properties of our input which will be helpful in solving our questions. So in this question we are said that the cell value, if it is equivalent to 1, then it is a land, and if the cell value is equivalent to 0, then it is then it represents water. And we know that island is made up of land. So what we need to focus on is, we need to focus on all the cells which are equivalent to 1 and they are connected, correct? And in the question itself it is given that there will always be one island present in the grid. So now we know that we need to focus on all the cells where the value is 1, and then we need to check for the parameter. Now if we see this yellow outline, what we can clearly see is this cell is equivalent to 1, right? That's the first thing. Second thing, the parameter is calculated with all those sides which are connected to water, not with any land. So if any side of that cell is connected to land, we are not considering it in our result. But if the sides are connected to water, then we are adding it up in our result. So this is the first observation that we are getting out of this diagram. So what we can do is, we can traverse this whole grid and we will check for all the cells, where the value is equivalent to 1, and then we can check their 4 sides and we will add them up in our resultant if the sides are connected to water, and if they are connected to land then we will simply leave it. So that is the first brute force approach. So let's see how this will work. So suppose this is our result. So I have cleaned this space. So now let's assume our parameter is 0 right now and we are at this place. So I will come up to this place. I will see that the value of this cell is 0. So I will simply hop on to the next cell. And at this position, I'll see that the cell is equivalent to 1. So I know this is a land. So what I need to check? I need to check up, down, right and left of this cell. And what I am checking? I am checking whether this side is water or not. So as we can see, this cell is having 3 sides with water. So what we are going to do? We are going to increment our parameter with 3. Correct? So now our parameter is equivalent to 3. Then we will move on to next cell. This is 0. So we will again proceed. And this is also 0. So we don't have to do anything. Then we will change our row. We will go to this row. And again what we see, this is a land. So what we are going to do? We are going to do the same thing. We are going to check all the 4 sides of this cell. So in this cell as well, we can see there are 3 sides which are connected to water, but 1 side is connected to land, which is not connected with water. So what we are going to do? We are again going to increment a parameter with 3, so it will become 6. Correct? Then we will move on to next block. Here we can see that there are 4 sides and all 4 sides are connected with other lands, right, which is a part of island. So we are again going to move on to next cell, because this cell doesn't have any side which is connected to water, so we are not going to increment anything. So we will go to this side, and this is also a cell with value equivalent to 1. So what we are going to do? We are again going to do the same thing. We are going to check all the sides, and after checking all the 4 sides, we are going to get that 3 sides are connected with water. So we will again increment 3 and it will become 9. Then we will go and check the next cell, which is water. So we don't do anything. We will go to next row. Here this is water, so next cell, and in this cell we can see it is a part of island. So again we are going to check all the 4 directions, and in this we can see 2 are connected with other parts of island and 2 are connected with water. So what we are going to do? We are going to increment our parameter with 2. Again, this cell is water, this cell is water. Next row, this cell is connected with 3 sides with water. So we are again going to increment our parameter with 3, and again another cell which is connected to this cell, but the 2 sides of it are connected to water. So again we are going to increment 2. I'm writing it here. Let's write it down here. So now this will become 9 plus 2, which is 11. 11 plus 3, 14. 14, 15, 16. So this is the parameter, because after this we are going to check, but as these are water cells, so we don't have to do anything. So in this way we will complete our traversal, and the value that we are having in hand is 16. So this is the resultant. So now we know that we checked all the 4 sides, and in this manner we calculated the parameter. So the time and space complexity of this approach will be big of m cross n is the time complexity, and space complexity will be big of 1, because we are simply using a variable parameter. We don't need any data structure in order to save anything. A parameter that we keeps on updating with all the new values, that is enough. So space complexity is big of 1, but time complexity is big of m cross n, where m is the length of row and n is the length of columns. So we are traversing the whole grid, that's why the time complexity is big of m cross n. So now can we do a bit better, or we can modify something in this approach? So yes, we can modify something in this approach, which is not going to change the overall space and time complexity of this approach, but yes, we won't be doing this much comparison or checking. And how we are going to do that, I'll show you. But yeah, in terms of space and time complexity, this change is not going to affect anything. So what we were doing previously was, if this is a cell, we were checking all the four sides of this cell, correct? And if the cell is connected with water, then we were adding it up in our parameter. But now what we can do is, rather than checking all the four sides, we can simply check the left and top. Why we can check this? Because we are traversing in this manner, where firstly we are traversing one row and we are traversing from left to right in this manner. So what we just need to check, if I am standing at this block, I just need to check that the previous block is land or not. Why? Why I need to check this? Because see this example. In this example, in second row, what we are trying to do is, we are saying I am standing in this block currently. Okay. So I am saying just check the left and the top. And if left is present, then subtract 2 from parameter. And if top is present, then to subtract 2 from parameter. Why? Because if we see this thing, so these are two cells, right? These are two cells. Individually, if for a moment I forget the whole concept of island and everything, we know that each and every side is equivalent to value 1. So if there is no land connected to this cell, the parameter of single cell is going to be 4. Correct? Of these cells, for every cell, the parameter is going to be 4. But now when I am going to consider the neighboring cell is also a land, and I need to subtract the value of the connected side. What I am doing is, I am seeing that this side is also connected to this cell which is on right and this cell which is on left. So this single side is connected to left and right. So if I see the total of these two cells, the total parameter of these two cells were 8. And because if this side is only connected, then what we are saying, subtract 2. Correct? So this will become 6. And if we see the diagram, so as I am saying, if this side is the only one which is connected, then let me just change the color so it will make more sense. So as I am saying, this is the only side which is connected, then this, and this, these are the one which will be considered as a parameter, right? I have made a mess in this diagram. Let me clean this up and I'll explain it to you all again. So what I am trying to say is, for a moment consider these are the two cells, correct? And rest of the space is water. So if I have to find out the parameter of these two cells individually, the total will be equivalent to 8, right? But now when I have to consider the island condition, that is the only edge which is connected to water that is being considered in our parameter, then what we are doing? We are subtracting that edge which is connected to land. And in this case, we are saying that if this is the side which is connected, then this will be subtracted for both the cells, right? So we will be subtracting 2 and this will become 6. And we can see that the sum of rest of these sides is also going to be equivalent to that. So this concept works, right? Now the point is, why we are only checking left and top? Why we are not checking right and down? So the answer to this thing is that we are traversing from left to right and from top to down. So if we are moving in this direction, we don't have to check the upcoming cell, we only have to check the previous cell, and that will be enough, because we are already going to get to this place which is the right side in the next step. And same goes for the downward cells or the cells which are in the next row. So that's why we are only going to check the left and the top. So now the approach will be a little bit different. So now what the approach will be is, again our parameter is 0 right now, and I will go to this cell. I'll say that this is water, so we don't have to do anything. Then I'll move to next cell, which is land. So what I will do, I will simply check the firstly I will simply add the parameter of this individual cell, which will be 4. So now my parameter is 4. Now what I am saying, check the left and top of this cell. So left of this cell is not 1, so we don't have to do anything. Top of this cell is not present because this is row 1. So right now we don't have to do anything, we have to move further. So I will go to this cell, this is water, this cell, this is water, so I don't have to do anything. I will go to next row, I will come up to this place. Now for this cell as well, what I'm going to do, I'm going to firstly add the total parameter of this square. Then what I'm saying, check the left and top. So left, currently there is no left because this is the first cell. Top one is water, so again we don't have to do anything. So what we can do is we can move to next cell. Then we will come to this place. Currently my parameter, previously my parameter was 8. Now as soon as I reach this place, what I'm going to do, I'm again going to increment 4. So 8 plus 4, and then after adding the parameter of this whole cell, what I'm going to do, I'm going to check top and left. So I can see that left is 1. So what I'm going to do, I'm going to remove this edge, which is -2. So I did that. Then I'm going to check top. Top is also land, so I'm going to again remove this edge. So this will also become 2. So now what my parameter is? My parameter is 8 plus 4 minus 2 minus 2. So it is 8. Now I will move to next cell. In this cell again what I'm going to do, I'm going to increment 4. That is the total parameter of this cell. Then I'm going to check left and top. So left is again, the cell value is 1. So what I'm going to do, I'm going to do -2. And top is water, so I don't have to do anything. So at this stage, what my parameter is, 8 plus 4 minus 2, that is 10. Now again I will move to next cell, which is water. Then we don't have to do anything. I will go to this place, which is again water. So I will go to next place, this cell. And for this cell again, I'm going to firstly add it in my existing parameter. So the 4 has been added. After that I'm going to check left, which is water, so I don't have to do anything. Then I will check top, which is equivalent to 1, that is land. So I will again subtract 2 and this will become 12. Then I will move to next cell, which is water, so I don't have to do anything. Then again next cell, which is again water, so I don't have to do anything. Then I will come up to this place where I will again increment 4 and check left, which is not there, so I don't have to do anything. Top, which is water, so I don't have to do anything. So at this stage our parameter is 16. I will move to this cell. So at this cell, what I have to do is, I will firstly increment 4. So again what I am going to do, 16 plus 4. Then I am going to check left. So it is a land, so I will subtract 2. Then I will check top, which is also a land, so I will again subtract 2, and this value will become 16. And rest of the 2 cells are water, so I don't have to do anything. So as we can see, after traversing this grid with this approach and calculating a parameter with this calculation, again the answer is 16. So as I already said, the time and space complexities are still same, but the calculation that we used is bit different. So the approach is a better version of what we discussed before. Rest, everything is same. So let's quickly code this whole solution. So firstly, let's define our parameter, which is 0. Then we need row count, so it will be length of row, so it will be length of grid, and columns length will also be equivalent to grid 0. After calculating row and column, we are going to traverse this grid. So for R in rows and for C in columns, this will be inside range function because this is number. So let's keep it inside this. And what we are doing is, firstly we are simply updating our parameter with 4, correct? After this we are checking if R is greater than 0, that is if the row is not the 0 row, then what we need to check is, we need to check the row minus 1 and columns value is equivalent to 1. So this is where we are checking the up cell of the current cell, upper cell of the current cell. So parameter minus equivalent to 2. And then we are going to do the same thing for left. So if C is greater than 0 and grid R C minus 1 is equivalent to 1. So if the left cell is equivalent to 1, then again we need to subtract 2. And after doing this whole calculation, just return parameter. That's it. Okay, one very important condition that we need to check before incrementing this parameter, which is really dumb of me. That is, firstly we need to check whether this grid is a land or not. Then only we are going to proceed with the rest of the calculations, right? Because if it's a water, then we don't have to do anything. So this whole calculation part will go inside this if condition. And now we can run this and check. Fine, let's submit this. Okay, so this is submitted. We can see. So this was the whole solution with explanation. And I hope this video was helpful for you all. And if it was, then don't forget to like, share and subscribe my channel. I will soon come up with more such questions. Till then, keep messing with algorithms and thanks for watching.